Welcome to Rewired, navigating AI's role in kidney health. This series will dive into challenges and triumphs as artificial intelligence continues to evolve in kidney care. Each episode will feature leaders in this new intersecting space.
This podcast should not be used in any medical emergency or for the diagnosis or treatment of any medical condition. If you have any questions about any medical condition or before taking any drug, changing your diet, or commencing or discontinuing any course of treatment, please consult your doctor or another qualified healthcare professional. Views expressed on this podcast are those of the speakers and not necessarily those of the American Society of Nephrology.
Welcome, everyone, to our podcast series focused on artificial and augmented intelligence and its relevance and application to nephrology. I'm Navdeep Tangri, Professor of Medicine at the University of Manitoba in Canada and Chair of the ASN Partnership for Responsible Augmented Intelligence in Kidney Health, a real mouthful. And joining me for this series is Karandeep Singh.
Hi, I'm Karandeep Singh, nephrologist and Chief Health AI Officer at UC San Diego Health, and a member of the ASN Partnership for Responsible Augmented Intelligence in Kidney Health.
Thank you, Karandeep. We've known each other for more than a decade plus now, and it's great to be doing this with you and sharing our thoughts and the thoughts of the ASN AI committee with the larger community of nephrologists and ASN members. So ASN started this partnership as a strategic priority for the organization. I think ASN felt that AI is really everywhere, and our members need a place to start, a resource to call their own, and we needed to bring some of us together to really make sure that nephrology is at the forefront and not left behind in any way. So let's get started. Why should we care about AI in medicine? And this is an ASN podcast, so why should we care in nephrology?
Well, I think if you look back at it, nephrology is a math-oriented discipline. The way that we learn nephrology, the way that we teach nephrology, the way that we experience nephrology is very kind of logical and mathematic, and we think a lot about physiology and pathophysiology. I wouldn't go so far as to say that medical calculators were invented in large part because of nephrology. Whether you're interpreting acid-base abnormalities or working up hyponatremia, there's physiology involved, and that means that there's math involved. So I think this complexity is why nephrology is often viewed as a cerebral discipline, but I think it's also why some folks end up shying away from the field. People look at it and they can get intimidated by some of those concepts in nephrology. And where AI comes in, I think, is that AI is a great equalizer. While it makes mistakes and there are a lot of issues with it, and those are issues that we are studying very closely, the fact that AI models have been trained on all kinds of data around the world, including text data, online data, textbook data, when you interface with these AI models, they have an understanding of physiology. They can do some basic math, especially if they're equipped with the right tools to be able to pull out a calculator and actually do some math. And what the end result of that is that I think that within nephrology, sure, there's a lot of things we can do, but beyond nephrology, it makes a lot of nephrology content accessible for people who it was previously out of reach.
Yeah, I think probably both of us were attracted to this field because of this love for math. And it reminds me of that football player from Ted Lasso. I think one of the seasons where, he's like, football is life. I think math is life to a lot of people who go into nephrology. And perhaps...
And I got to say that, this is the ASN podcast, so I think we call it soccer.
So this is true. This is true. But it does have a global audience. So we'll argue about that at another time. But let's think a little bit about, math and deep learning. And this has been around for a long time. But in how the consumer or the average ASN user, how they interact with math and how they interact with deep learning has really changed since the introduction of generative AI. I mean, you could almost point to like a pre-generative AI era and a post-generative AI era. So tell our users, what do you think is an easy way to differentiate conventional sort of ML and generative AI?
Great question. So I think, machine learning models, and especially supervised machine learning models, which are basically, all that means is that you have a model that you're building to try to predict an outcome. And that outcome, the fact that you know what the outcome is the part that makes it supervised. You're showing it examples with predictors and outcomes, and you're asking the model to follow a training procedure to be able to learn that relationship between predictors and outcomes, and usually produce things like probabilities. So these machine learning models have been trained to predict outcomes for a given set of predictors. And that's the way we've been doing things going back decades. The fundamental thinking there is that every time you want to solve a problem, you really start from first principles, which is predictors, and you really map things all the way to the outcome using these models. And this turns out to have major sample size implications, because every time you're starting completely from scratch, connecting predictors to outcomes, you really need to have a large enough sample size whereby if there is a relationship there to be learned between predictors and an outcome, that your machine learning model can learn it. When we talk about generative AI, what we're really talking about is something called a foundation model. Foundation models are basically a type of deep learning model whose goal is to learn a representation of data. Usually that's text data, but it could also be imaging, it could be video data, and usually we call them generative models because they can generate text or generate imaging or generate video data in response. So early foundation models, especially those using text, you could really just think of those as supervised machine learning models or prediction models, because what they would do is they would take all the words up to a point in a sentence and try to predict the next word. And there were kind of simple ways to do that. There were more fancy ways to do that. But that's what some of the early foundation models really were. And foundation models and generative AI models in general go back much, much, much further than just 2022 when ChatGPT came out. It turns out it's actually fairly easy to predict the next word. And that's why we've had autocomplete on our phones for many, many years.
A long time.
But predicting the next sentence, predicting the next paragraph, that actually becomes very difficult, because now there are these long-range dependencies where something that you said 2 paragraphs ago, you want to allude back to it. And simple prediction models just simply can't do that. And they really struggle with that. So some of the kind of things that have led from that journey from machine learning models over to generative AI models is that there have been, these new architectures coming about. Architecture is just a way to describe the functional math formula used by a deep learning model or a neural network to learn that relationship. And so one of the things that came about was a type of model called a recurrent neural network, which was a model type that could predict sequences of data, which people often try to use to be able to do that next word, next sentence completion. But actually, probably one of the biggest breakthroughs in this field came with the invention of an architecture that deep learning experts refer to as a transformer. We won't get into the details of what that is, but the key thing to know is that it was able to actually represent and learn these longer range dependencies, where something that you said 2 paragraphs ago were still in the model state where it could actually refer back to it. It wasn't like it got forgotten because it was too long ago, which is what a lot of these other models were doing. And a example of a model that you may have never heard of, but you've definitely heard of the subsequent ones that was an early transformer, was GPT-2. GPT-2 was a model that did a great job of predicting the next word, predicting the next paragraph, and yet it was completely useless because if you told it to do something, it actually couldn't do it. So, we can talk about the next major breakthrough, but I think the next major breakthrough really was that it turns out once you've got something like GPT-2, a basic foundation model that can predict the next word, you can now fine tune it to be able to do things like follow an instruction. And that's an incredibly important concept. And it now has major implications on sample size, because even though GPT-2 required this massive training data, to actually fine tune it, you actually don't need nearly as much data. And so now suddenly you're able to fine tune it and follow instructions. And so that's what led us, I think, into the modern era, where we're interacting with tools now that largely are tools that follow instructions. So GPT 3.5, GPT 4, 4.05, Claude, most of the things that we are kind of familiar with in our day-to-day, if we're interfacing with these generative AI models, those are all kind of models that follow instructions. And then very recently, they've been superpowered with the ability to have something called tools. And tools are just kind of individual capabilities that you tag onto these models. For example, searching the web or checking the weather. And then once you have these tools that you can, provide to the language models, now suddenly it doesn't say, I can't tell you what the weather is today because I was only trained through data up until 2022. Now it can say, even though the language model was only trained up until 2022, I can do a web search, check the weather, and tell you the weather today. And so that's kind of the really big capability. And I would say, the bleeding edge of that right now is that you can have these specialized foundation models that do individual things. And that's why there's all this buzz now about something called AI agents, which are essentially these specialized foundation models that have access to tools that can actually do useful things for you. And now you can chain them together. And suddenly, things that you really thought of as things that you had to talk to a human to do, you can chain these agents together and kind of get close on at least some of these tasks.
Well, that's an incredible overview. Thank you for taking us all the way from the beginning and kind of because I think a lot of our audience and many of us even who work in the field really only think about generative AI from 3.5 and onwards, from 2022 and onwards. And I think a lot of people maybe are not making the little connection between auto predict on your phone or on your Gmail and how that was kind of the beginning of the early days. In a sense, I guess the backbone uh, of of it is the same, a model trained on a set of data, but instead of pixels and numbers, which is where deep learning, machine learning comes, here we're talking about billions of words from textbooks and websites, and all that does is gives the model an ability to truly understand natural speech and natural instruction, and then finally in this new era, as you highlighted, actually take actions that can make humans' job easier, provided we give the instructions in a way and provide some safeguards and fencing around it. So health systems in the US probably are seeing these solutions pitched all the time. And I'm thinking about agents and I'm thinking about things to do tasks that automate workflow and perhaps ahead of smaller practices in a way because health systems can be considered larger customers for those for these vendors. So in your position, you're a chief health AI officer at a large health system. How do you look at these solutions, these agents or models, and look at them for validity, usefulness, ROI? When someone says, "I have something that's going to fix all your problems," how do you cut through the smoke and find the truth?
Yeah, so I'll just start by saying, even though I'm the chief health AI officer at a health system, there are many folks in our health system who do AI work. And so a lot of my focus at the level of validity, usefulness, and ROI is really thinking about the way that we deliver care and kind of a healthcare operations and delivery level of thinking. There are lots of AI models coming in all these different clinical areas, including nephrology. And I think for those, I don't view it as my job to necessarily look at the validity, usefulness, and ROI of that tool, but that's where we really kind of lean on our clinical partners to try to figure out what would you do with this information? What's the value? And then we can try to tie that back to a return on investment, or is the juice worth the squeeze? Because none of these things are free. They all come with a cost, at least in the medium to longer term. So I would say that, because of my role and because of just the connectivity that I've been fortunate to have into the rest of the healthcare system and the way that we deliver care, we in general, I would say, would have a fairly good sense of where we want to go in terms of what our focus areas are for using AI, where we do want to use AI and where we don't want to use AI. So when we're talking to AI vendors, certainly we're interested to hear about what their ideas are, how they see what their kind of product does, and what the value it brings. But we're often kind of trying to fit that into the rubric of where might it fit in our delivery process and really on our broader health system kind of strategy. We don't have a separate AI strategy. A lot of people say, oh, an AI officer develops an AI strategy. We have an AI strategy that deals with things like infrastructure. Where do models sit? Where do things happen? How did things get connected from our data back into running a model and then filing a prediction back to an electronic health record that is visible to a clinician? Those are pieces that are AI strategy. But the broader use of AI is actually part of the broader health system strategy. So I would say that the vendor-centric view is that, you see all these solutions and you're trying to think, well, what should I do? What should I not do? That's an inverted thing. We kind of know where we do well. We know where we don't do well in terms of quality of care, in terms of the way that our health system runs, and the experience that our patients have and the experience that our clinicians and staff have. And so largely, we're trying to put that tool into a larger framework. We do carefully think about, do we build or do we buy for various kind of things? Most times I would say the kind of the leaning is to buy something because you recognize when you build, there's a whole kind of tech debt that you're going to be taking on with a responsibility to maintain. But even when you're buying, you have to think about, are we going to buy a point solution? Are we going to buy a platform? And unfortunately, the biggest challenge right now isn't triaging these point solutions. It's that every single point solution vendor is saying that we're actually a platform vendor. And there's a huge convergence happening. Whereas before, there was companies that you would think of and say, oh, that's a company that focuses on billing. And that's a company that focuses on documentation. Right now, every company does everything. And
I
that's
think
maybe an
this
overgeneralization, but I think that's actually true.
And I think this goes back to your first point early on about how AI being an equalizer. I think because coding is so much easier now, right? If you think about where there's some areas where there's really like this transformative impact of generative AI, one of the areas that I could point to is coding, right? So if you can just code so much faster, if each developer at these small vendors is now doing the job of three developers, and they can buy and get access to the best generative AI models for like pennies a token, all of a sudden they are able to diversify and say, hey, I offer everything. And so that really becomes an interesting challenge.
One question I'm always thinking about when we're looking at these, generative AI tools is how many degrees of freedom is this away from off-the-shelf ChatGPT?
Yeah.
There are many things where a vendor is kind of showing you something and it's incredibly impressive, but you also know that you can recreate the core functionality in like a weekend because the core magic is actually off the shelf large language model and not necessarily the other piece. So actually a lot of the value add when we look at these solutions is really what are they adding that isn't simply ChatGPT? What are they doing on top of that? What are the integrations they have? That's really the value. And that's oftentimes the way in which we're looking at these tools and trying to figure out, how much work would this be to do for ourselves and how much value would it add to something that we currently do in a really clunky way. And in many cases, the generative AI way substantially outperforms the kind of status quo.
So I think my own bias here is that we nephrologists, practicing clinicians, can add that extra value. That if you have deep insight into the clinical problem that the solution is trying to solve, and you embed that insight and you make the solution really responsive to workflow, you're always going to have an advantage over somebody who's just, throwing something off the shelf. And then now you have access to all this off the shelf stuff. Your clinical, solution to a clinical problem is better. So let's get back to nephrology. So what do you think our nephrology colleagues who are listening to this podcast, what are they getting pitched? And how should they evaluate them?
Yeah, so I think that interestingly, one thing that we're seeing is that the same thing that health systems are getting pitched on, our nephrology colleagues are getting pitched on, but for nephrology. And that's true across many subspecialties. So there may be AI scribing tools that we use in an enterprise scale. Guess what? There are vendors out there pitching AI scribes for very bespoke clinical areas out to different specialties, including nephrology. There are chatbots where it's like, oh, I'd love to do a patient follow-up after they leave, or get some measure on blood pressure, things between visits for a dialysis patient as an outpatient, where a chatbot might be a great solution. Well, guess what? There are chatbots that are specialty specific, where it's kind of like use this chatbot for this specialty. And what I can tell you is that one of the things that we really struggle with is it's a game of whack-a-mole. In some cases,
Yeah.
the actual specialty specific tool is substantially better than the generic tool with a little bit of domain expertise added to it. But I would say probably half the time, if not more, the actual magic is not the actual specialty tool. It's the overall thing that it's doing. And so a lot of it is actually making sure that the left hand of the system talks to the right hand of the system. So if you're a kidney doc and you're getting these pitches from kidney companies, try to understand what's the larger trend and what's the larger, more general product, and what's the delta between the general product for the chatbot scribe, whatever it is that you're kind of been getting pitched, and the kidney specific component of that. And the delta of the value there is a lot of what's going to drive, I think, which drive your decision, especially if you're in a multi-specialty practice or a larger center where it's not feasible for us to have IT support for chatbots that are 8 different vendors for 8 different specialties. Just doesn't work, doesn't scale.
Well, thank you. I think you've really given us an incredible introduction to AI, particularly generative AI, and from your unique perspective, which is a leader in a large health system. Now, this is only the beginning. tell our listeners what they can expect from the next podcast in this series.
Yeah, so we recognize that this podcast is really intending to serve a fairly broad set of listeners. Some of you will have experience in AI, others may be kind of curious about AI, and others may be very skeptical about AI. So I think the idea here is that we are going to put together a series that's responsive to a broad group. We're going to dive into some basics of machine learning and, what is it? Try to unpack it beyond kind of that very superficial level, but a little bit deeper into the what is machine learning and why do people write in their papers things like leveraging machine learning? We'll get into things like use of AI in medical education. It's obviously a big challenge that everyone's facing. How do you assess med students? How do you assess learning in the era of generative AI, where you can just ask an AI a question and get an answer that can be copy pasted into assessments of medical knowledge? Ethics of AI models, and we'll talk about that in kind of a variety of different scope and areas, but we'll dive into ethics of AI models, for example, in allocating kidney transplant. We'll get into models that influence dialysis care and how to implement them. And then I think we'll continue to highlight papers that come out as they come out. And so I think don't be surprised if something comes out and we do a bit of a commentary on what do we think that paper means to the field, in a kind of, just from our take in our various roles as health system leaders and as researchers.
And for everyone who's listening today, this podcast is not the only thing ASN is doing. ASN members can join us online in the ASN community, the AI-powered Kidney Care Network. Please log into the ASN website and follow the ASN AI community for regular updates. It's active. There's tremendous content being posted, and we want you to join. In closing, Karandeep, what are one or two things a nephrologist should do or a resource they can access between listening to this episode and the next episode?
So I would say the community you just referred to, our ASN community, that's a great place to post questions that you have or post papers that you've come across and get thoughts on it.
Thank you so much, Karandeep, for joining this podcast and helping launch our new series. Speaking for both of us, we're so excited to work together and help the nephrology community stay current and ahead of the AI curve. Thank you, everyone.
Thank you for listening to this podcast by the American Society of Nephrology. I'm Todd Ibrahim, Executive Vice President of ASN. If you're a nephrologist, fellow, or kidney health professional looking to advance your career, stay informed, and build connections, I encourage you to become an ASN member. Membership, which is free to fellows and other trainees, offers exclusive access to groundbreaking research through our journals, discounts to live and virtual educational programs, including Kidney Week, and support of a global network of nearly 22,000 kidney professionals. To learn more or join ASN, visit www.asn-online.org.